My name is Ann Hanks. I'm one of the product managers here at Pasco. So today I'm going to start by talking about the steam generator, which is brand new, a new design. And so basically you're going to watch water boil today. This new steam generator has carrying handles and it has 9 power settings. Let me just turn on the switch here and click the button. And that's probably on about setting number 9. Currently, I don't have any water in here. And so what's going to happen is it's at 0. All right. Now it's at 9. What's going to happen is it's going to overheat. And I'm doing this on purpose because I wanted to show you that it does have a low water indicator, and that will come on. And then it also automatically shuts off the power. Okay, so now it's overheated. And until I add water or turn it off and let it cool down, it's not going to operate. So I got some water I'm going to pour in here. And so now I should be able to adjust this again. That's probably on 9. I'm going to go down. Oh, up 1. Okay, now I'm level 1. And also, one of the safety features here is that there is a safety valve so that when the lid is on and you're producing steam, if the hose becomes kinked and it starts to build up pressure, it will release that pressure through this valve. So I think that we were interrupted there. So I'm just going to go back to talking about the spout for pouring. It's very convenient because you can disconnect the power cord and carry it over to a sink and pour the water out very safely. The lid has a special switch in it. So this actually detects when the lid is on, and it won't boil unless the lid is in place. So it will get up to a certain temperature and then just hold at that temperature depending on what the setting is. So one of the applications of this is to use it for specific heat experiments where you can take a sample and just lower it into the hot water and get that up to a certain temperature. And we can measure what that temperature is with a sensor. I'm going to show you that right now. I have a wireless temp link, which allows you to plug in various probes to it. And it is wireless, so I'm going to turn it on and connect wirelessly to Capstone, is the program that I'm using. This works in SPARKvue as well. Here. So now I'm attached to this in the program, and I'm going to stick it in the water just to see what the temperature is on that setting. And it looks like it's at about 50 degrees. The thermometer's coming to equilibrium with the water at the moment. Then if I change the setting to, see, I'm just going to find the button. Here's it. Right there. So that setting is about 5. And we'll see that it's going to increase the temperature now. and it'll come to a new plateau. And so roughly between setting 1 and setting 9, it goes from about 50 degrees Celsius up to about 92 degrees Celsius. So, but it will hold it at it's not exact temperatures, but it will hold it at that temperature for each setting. So let me go on up to 9 now. And there's 9. So that's not going to boil it though, because we don't have the lid on. I'm just going to stop this for a moment. When the lid is on, the numbers do not correspond to temperature. It will boil and produce steam at even number 1. But what the numbers indicate at that time is, with the lid on, is how much steam it's going to produce, the rate at which it's going to produce it in grams per second. So I'm going to get a lot of steam because I'm going all the way up to 9 so that I can do my experiment. One experiment that you can do with this is our thermal conductivity experiment. But the one we're doing today is the thermal expansion experiment. So I just want to show you here the thermal expansion. These are tubes, and we're going to put the steam through the tubes, and that's how we're going to heat the sample, and it'll expand. This comes with storage, so there's a couple of these stored on here, and I'm going to take them away right now because we're just going to do the copper one. As the tube expands, this end is free to move, and this end is fixed. So there's a set screw, so it can't move. So we'll be measuring how much this portion of the tube expands. There's a dial gauge here, which tells me how much it's pushed up against this stop here. And that tells how much it's moved, how much change in length we get. There's a thermistor that comes attached to each of these tubes. And I can't show it to you because it's screwed in to the middle here, and there's a insulating foam around it. And normally you would plug this in to the device. There's a jack there. And if you wanted to use a multimeter to read the temperature, there's jacks to plug in the multimeter right here. That gives you a resistance, and then you would have to convert that resistance to a temperature, and we have a table that allows you to do that. Because I don't want to take time doing that, I'm going to use my handy dandy temperature sensor. I'm going to take this probe off and put the thermistor directly into this. So this temperature sensor is going to read the temperature directly. So to do the experiment, one of the nice tricks about having this steam generator, the way it works, you can get the temperature of the water pretty hot, but I'm not ready to do the experiment yet, so I don't want to start the steam going through there yet, but I do want the steam to go through there fairly quickly after I begin the experiment. So I'm going to put the tube onto the steam generator lid, and then I'm going to put the lid on here, but I'm not quite ready because I, first of all, would have to measure the length of this, which I did previously. And I put that length in my file here. It's 750 millimeters, and I'm using millimeters because the gauge is going to give us how much it changed in millimeters, and I want those two units to cancel out. So I need to turn on the gauge, and it is 0, and it's up against that. So we're ready to go now. So I'm going to start recording. And you can see that the tube currently is at 23.4 degrees. And now I just put the lid on and it's going to start producing steam. We can watch the dial here to see when it starts to get hot and the whole thing starts to expand. Because the thermistor is in the center here, it'll take a while for the temperature of the tube to change in the middle, whereas the expansion is going to start right away. So we'll see the dial begin to change as soon as the steam starts to come out. No steam yet. But then, oh, I'm starting to hear it. It's going to start expanding pretty soon here. So it doesn't take a lot of time for you to get going on this experiment because we preheated the water. Oh, there it goes. It's expanding. And this gives a negative answer, but that's because of the direction it's moving. So it's up to 0.96 millimeters. And it's pretty much stopped. It may go a little bit more. We'll see. But in the meantime, when we look at the graph of the temperature, you see that the temperature is still rising, even though the expansion is pretty much done, because we have to wait for this whole tube to come to equilibrium at a certain temperature. So you don't want to stop just recording the temperature just when the dial indicates that the expansion is done. You'll miss the total temperature change. And it did go up one more digit here to 0.97. I'm going to assume that's going to be it. Might go up a little bit more, but I'm going to put in 0.97 millimeters. And since that is just about a millimeter, you can see why you need to have a dial gauge to record it. You wouldn't be able to see that change in length. I have the calculator already prepared here with the calculation to find the coefficient of thermal expansion. So I'm going to put in my delta L is 0.97 millimeters. And we don't know about delta T quite yet. You can see the temperature's up to 97. It's getting pretty close to being the end there. And it's still reading the same. Okay, so I think I'm going to stop at this point and turn off the steam so it can cool down. I need to know delta T, so I'm going to go to my graph and get a tool, the coordinate tool. There we go. And go down to where we started, get a delta tool, and move that out to where we stopped. And it says delta T is 74.2 degrees. 74.2 degrees. Putting that into my calculator, 74.2 And you see that here's the result of that calculation so that you can see it. 17.4 times 10 to the minus 6 per degree Celsius. And the accepted value, this is for copper, is 17.0. So that's a pretty good result there. So you can see this works out to be a fairly fast running lab. You could do other tubes in the same lab without much trouble. That concludes the webinar. If you have questions, you can contact your representative from Pasco. Take this lid off here. And just to show you how great it is at boring, this is the sort of thing that you don't want to do live in class, but it's nice to feel fairly safe with boiling water. Thank you.